So as we've been learning for the past couple weeks, once we have our pieces factored, then we can move to solving, finding the roots of our equation. And remember, because this is a square, this is called a quadratic, and that literally, if we were to graph it on a coordinate plane, it would look like this or like this. It kind of depends on if it's opening up or down. But this is what they look like. So on a coordinate grid, they pass the x-axis twice. Sometimes they'll only pass once if they actually are sitting right on top of it like this, but usually it's twice. There's usually two roots, which we also call zeros. So just a reminder of that one. I know I've gone over it before in other videos, but that's the idea. When we say finding the roots or finding the solution, that's what we're looking for. Is where does it cross the x-axis? Where are my zeros? So now that we know this pattern of the difference of squares, let's go ahead and use that to help us solve an equation. So this one actually has two different methods, and I'm going to show you using the difference of squares and then also using what is called the square root property. So we have v squared equals 16, where v is a real number. Simplify your answer as much as possible. So they want us to solve this. They want us to find the zeros. So first, let's get all the terms to one side of the equal sign. So what that means is if it's v squared equals 16, well, I don't want them to be on different sides. I want them to both be together. So I'm going to subtract that 16 on both sides like that. And I'm going to have v squared minus 16 equals 16 minus 16 is 0. So it cancels out on this side, but it's that 0 that I was looking for. So now I have the difference of squares idea. So I can go through and say, well, what's the square root of v squared? Well, that's v. Because remember, this means v times v. So if I have two v's, the square root is just one of them. I'm asking, when I say what is the square root of a number, I'm asking, what number did I multiply by itself to get there? I multiplied v by itself, so the answer is v. 16, well, the square root of 16 is going to be 4, because 4 times 4 gets me 16. So now I have my two pieces, and I can put it into the factored, our factor form using the pattern of difference of squares. So remember, for a difference of squares, I'm going to have 1 plus and 1 minus. So I'm going to have v plus 4, v minus 4. So this is essential because if I were to multiply these back together, I'd have v squared, v times v, v times negative 4, which would be negative 4v, 4 times v, which would be positive 4v, and then 4 times 4, negative 4, which is negative 16. If we notice there's negative 4v and positive 4v, they cancel out, which is why we come to just have v squared minus 16. And there is no middle term, like when we were factoring some of the trinomials in previous weeks, or actually in the previous section. So that's an essential part. We need 1 plus, 1 minus. They're identical otherwise, because then that cancels out that middle term for us. So now we can find the roots. I can go v plus 4 equals 0, v minus 4 equals 0, just like that. Okay. And so all I have to do is say, what does v equal now? I'm going to subtract 4 from both sides. So 4 minus 4 cancels, and I have negative 4. I'm going to add 4 to both sides on this one, because remember, I'm always trying to do the opposite of what's being done. So 4 minus 4 still cancels, but this time I get positive 4. So my roots are negative 4 and positive 4. Those are the two places that it's going to cross the x-axis. So if you notice, and I hadn't brought this up quite yet, I ask up here, hint, what is the square root of 16? Well, the square root of 16 is 4, and this should say r. I forgot to change that word. What are the square roots of 16? So there's a couple typos there, and I'll have to fix that on the worksheet. But it's not just 4, because I could go 4 times 4, and that would get me 16. But I could also say negative 4 times negative 4, and that will get me positive 16. So it's both 4 and negative 4. Oh, isn't that exactly what we got down here? Yes. So that's kind of the hint there. This is literally called the square root property. By just taking the square root of both sides and saying, okay, well, the square root of v squared is v, the square root of 16 is plus or minus 4. And this little plus or minus means positive 4 or negative 4. It means both. I don't think Alex will actually let you put plus or minus in for whatever reason. I haven't seen that symbol yet. So it'll have you type in 4, comma 4, like that, -4. So just be aware of that one. So this one down here is a little different because when I move that -49 over to the other side, just like I did with the 16, I'm going to add 49 to both sides. So I'd have v squared plus 49 equals 0. Because remember, I added 49 to both sides like this. I'm just kind of squeezing it in there. So the 49's cancel. That's why we have 0. And now I can kind of keep going, and I might not notice what's happening here if I'm not paying attention to that pattern that I'm supposed to be having. So with this one, I said the pattern we're using is called the difference, and I did this in capital letters, of squares. Difference of squares. So the big problem here is that's not a difference. That's a sum. This is not the same pattern. So I could very well take the square root of v and the square root of 49, which would be v and 7, and then I can go v plus 7, v minus 7 equals 0. But the problem here is if I actually multiplied it out just like I tested this one, I would end up with v squared minus 49. Not plus. I would not come back to the same equation. This would not work out. And if I kept them both plus, I would have a middle term. They wouldn't cancel out like they were supposed to. So be very careful about paying attention to that pattern, because you could very well keep going here without noticing it. It'll all mostly work out the way it's supposed to. It's just not going to have the correct numbers on it because it's not a minus here. It's a plus. So this one's a little different, because if I actually did the square root property on this, if I did this on a calculator, this is going to give me an error because I can't actually have this negative square root. It's not a real number, and they want a real number. We do have what's called imaginary numbers, which we'll get into a little bit later, but for right now they want a real number, which means that this is not possible. Okay, so just be very careful about that as you're going through and you're looking at these, that you're paying attention to those patterns. It's very important that we're looking at the details, okay? Because with this one, I would have 7 times 7, 2 positive 7s would give me a positive 49, not a negative 49. And same thing if I had 2 negative 7s, it would give me a positive 49. I can't have negative 7 times 7. That's the only way to get negative 49. But that's not a square because they're different numbers. One's positive, one's negative. So just, be careful about the patterns there. But all right, that's it. So go ahead and give it a try on Alex now.